let's go through and let's see if we can label all the quantities that they gave us. All right, it says here, you measured the pressure on a 32 meter cubed bounce house. So meter cubed means volume, so this would be my volume 1. That would be my volume 1. So I'm going to say volume 1 equals 32 meters cubed. And find it to be 150 kilopascals. Well, kilopascals measures pressure, so when this thing is 32, the pressure is this, so we're going to call this P1. P1 equals 150 kPa. If your entire class jumps onto the bounce house and stays there, the volume is reduced to, okay, so it's telling us we have a volume and it's telling us it's reduced. So this is a new volume, so I can't call it V1, so I'm going to call this V2. So I'm going to say V2 equals 21 meters cubed. What is the new pressure reading? Okay, in other words, what is the pressure when this thing is 21? What is the new pressure reading? So P2 equals X. If you look at what we were supplied with, we were just supplied with P's and B's. So whose law are we going to use? Are we going to use Boyle's law, or are we going to use Charles's law? Well, Charles's law includes volumes and temperatures, and nobody said anything about what the temperature was that day. So the only thing we were provided with were P's and B's, so we're going to use Boyle's law. So now I'm going to write the formula for Boyle's law. P1V1 equals P2V2. And I'm going to plug in the numbers. P1 is 150. V1 is 32. P2 is X. V2 is 21. Now I'm going to wait 5 seconds while you pause the video and you work this out. All right, hopefully you worked this out on your own, and you should have gotten 229. Now it's a pressure, and in this problem the pressure is measured in kilopascals, so this is going to be kPa. And if you're using correct sig figs, we are only allowed 2 sig figs in our final answer. So we're going to change this to 2.3 times 10 to the 2 kilopascals. Some students say to me, why can't I say 23 times 10 to the 1? You technically can, but remember the correct format for scientific notation is a number, a decimal, and all your other numbers times 10 to whatever your power is. A number, a decimal, and all your other numbers. So that's problem 1. It says if the bounce house says the material it is made up of can only withstand 175 kilopascals, are you and your classmates in danger? Solution says 229 with everyone jumping on there, but the instructions say it can only withstand 175. So, oh my goodness, yes, you are in danger. And half of you need to get off, or at least a third of you need to get off. So yes, your classmates are in danger. And plus, they're not social distancing if they're in a bounce house anyway, so double danger. All right, so there's our first practice problem with Boyle's law. Number 2 is another bounce house problem, and it says you know the total pressure, and then it gives you a volume and a pressure. What is the smallest volume the bounce house can withstand? Should you place limits on who and how many can bounce on your house? Well, before we even work out the problem, I'm going to say, oh yes, most definitely you should, because based on the previous question. So I want you to try this one completely on your own, number 2. And on my next video, I'll give you the answer to number 2. All right. Let's go on to number 3. In a very exciting chemistry lab, are there any other types? You take an 18.9 centimeter cube balloon at room temperature, and they give you the room temperature. So this is going to be my volume, and this is going to be my temperature at that volume. So that's going to be V1 and T1. So I'm going to write that down. V1 equals 18.9. T1 equals 23. Now, as soon as you see degrees Celsius, a bell should be ringing in your head. You cannot do gas law's problem if temperature hasn't been converted to Kelvin. Why? Kelvin doesn't have negatives and Celsius does, and you can't have negatives and make this work. So we're going to add 273.15, or this only has 3 sig figs, so we're just going to add 273. So 23 degrees Celsius plus 273 is going to give us 296 Kelvin. So that's the temperature that goes, that's our T1 that goes with our V1. Now it says you plunge it into some ice water. What is the expected volume of the balloon at the ice water temperature? And what percentage of its original volume does it lose? Okay, so they want a V2. That's going to be my X. But what on earth am I going to put for my T2? Well, the clue is ice water, and we know that ice water at standard pressure is going to be 0 degrees Celsius. Can you see why we can't use 0? Because if we divide by 0, we're going to get an undefined answer. So we're going to add 273 to that to convert it to Kelvin, and we're going to get 273 K. Obviously now, this is not a Boyle's law problem. This is a Charles' law problem. How do I know? Because Charles' law compares volume to temperature. Direct relationship, direct divide. So we're going to divide the quantities. V1 over T1 equals V2 over T2. Then we're going to plug in 18.9 divided by 296 equals X over 273. Now I'm going to pause the video for 5 seconds while you solve for X. Okay, when you solve for X, you get 17.4. And folks, what is my units? Well, way back up here, my units for volume was centimeter cubed, so my units for volume has to stay centimeters cubed. And in this one, I can only have 2 sig figs in my final answer because of this. Whoops, I thought that was highlighted. That's 23. So my answer would be 17 centimeters cubed. Let's now solve for the percentage. It says, what percentage of its original volume does it lose? Well, it started at 18.9 and it ended at 17.4. So it lost 1.5 centimeters cubed. And the question says, what percentage of its original volume? So it lost 1.5 centimeters cubed of its original volume. Its original volume was 18.9. So 1.5 divided by 18.9 times 100. I'm going to pause. You pause the video and work it out. And you should have gotten 7.9%. So it lost about 8% of its original volume. So that would be hard to see with the naked eye, especially in a round balloon, but maybe if you had an original one to compare it to. Let's look at number 4. If the volume of your car's airbag has an expected size, so here's V, at 35, here's T, so these two go together, so we're going to call them V1 and T1. What would be the expected size? So we're going to do V2 is going to be my X. If you drove to a place with your windows down that had near freezing temperatures of 1 degree Celsius. And actually, let's change that to what would be if you drove it with, we'll keep it at 1 degree Celsius. Okay, this is a whose law problem. It's V's and T's. It's going to be a Charles law problem. And then for number 5, it says if the temperature dropped below freezing to minus 10 degrees, what would be the volume of the airbag? So I'm going to leave you to finish those two. And remember, you're going to write your givens, write your formula, plug in, chug out the answer, answers with units. Okay? So show all your work and finish this worksheet.